for slab on, let's say, starting last week. But because of all these causes that are out of our control, we could not pour the slab, which means that it's going to have flow-on effect on other tasks that were dependent on the slab being poured last week. So all the other tasks that are directly or indirectly affected then have snowball effect on other related tasks. But as construction managers, it is really important for us to understand the changes and what would be the flow-on effects to the other tasks. If you are just looking at the schedule, if you're just looking at the program, it's really hard for us to understand what the flow-on effects will be on the other construction tasks. And that's where a BIM-enabled environment provides us the foundation to visualize the changes and better understand impacts on the other tasks. Because a BIM-enabled environment allows you to visually see the elements, the items in the data or in the BIM data that would be affected directly or indirectly because of the changes. And that's where we use a program called Autodesk Navisworks. Some of you have already would have used Navisworks, but for people who do not know what Navisworks is, Autodesk Navisworks is a design collaboration tool. So it's not a design creation tool. It's a design collaboration tool that lets you bring in the BIM data from different disciplines like structure, mechanical, architecture, electrical, plumbing, hydraulics, civil, and creates a full federated model. So once you have a BIM-enabled environment, Navisworks then allows you to run various planned versus actual simulations to help you understand what these visualization or what these changes are. So it will help you visualize the changes and the flow-on effects of changes in various construction tasks. And that's the session today that I want you to present. Now, talking about planned versus actual simulation, as I mentioned, Navisworks allows you to display or visualize various planned versus actual simulation. So in these simulations, what we do is there are two types of dates that we've got in the schedule. We've got the planned dates and we've got the actual dates. So the planned dates are, for example, as I mentioned earlier, we were supposed to pour the slab last week, but we were not able to pour the slab. So the slab pouring started today. So planned date was last week and the actual date is today. So we've got the planned dates and the actual dates in our schedule. And then the actual dates are the tasks that would, as I said, could not be started or finished on their planned dates. Now, it's not just starting of the task, it could also be finishing. So for example, we were supposed to erect all the steel work on level 1 and level 2. But for some reason, the steel was not delivered on time, or for some reason, we had problems with labor because of which the steel was not erected. It could not just be the start date, it could also be the end dates of those tasks. So once we've got the planned start and planned end dates and the actual start and actual end dates, Navisworks then allows us to play planned versus actual simulation and gives us a visual feedback of the tasks that are behind the schedule. So we can have these tasks that are behind schedule displayed in different colors for us to understand what are the flow-on effects on various other tasks. What I'm going to do is I'm going to get straight into the live demonstration of this now. So let me switch over to Navisworks. So this is Autodesk Navisworks interface, as you could see here. I've got a model of a hospital project here. I've also got a few cranes around it, and I've got some temporary construction, which could be these temporary buildings that we construct on site during the actual construction process. But the temporary items could also be things like scaffolding and so on. So Navisworks has got options for us to simulate all these elements. But before we get into simulation, let's quickly have a look into this model here. So if I look at my selection tree, this model basically has got the structural, HVAC, electrical, plumbing, architecture models, and we've got some site offices, we've got tower cranes and so on. So if I, for example, go into my structure model, and if I say hide unselected, we can see the structure model only. So this is a federated project where I've got all these different discipline models. Now, the good thing about Navisworks is when you bring in these different discipline models, Navisworks allows you to bring in files from about 50 different formats. So we've got all these different formats that we can bring the files from. In this case, it's a Revit project, hence you would see all these files as Revit files. There are other different formats that you can bring in, and most importantly, you can bring in Ifc files as well, just in case you work with Ifc. Now, as I mentioned earlier, the good thing about Navisworks is when you bring in these various discipline models, it also brings in all the metadata with those models. So for example, if I click on this column here, in my properties window, it gives me all the properties of this column. So I'm looking at this column right now, and it's telling me it's actually a Revit column, and I can see that because I've got all these different Revit tabs. So there's this tab here called Element tab, where I can look at all the different element properties of that selected item. So it's telling me that it's a W wide flange column, it's a structure column, that's the category. And then we've got all the related information here as well. Similarly, if I go to, for example, the mechanical model, and if I say hide unselected, I can now click on any of these duct items and tells me that this is a duct item, it's a rectangular duct, and all the other related information. Now, please note that this information is coming from the additional authoring tool. And again, because this is a Revit element, so all these properties that you see here are basically coming from Revit. So most of the authoring tools would let you bring in their metadata into Navisworks. So it's not just a dumb 3D model that you're looking at, it's an actual BIM data. That means that it's got all the specialized properties or the metadata that you really need for your construction. So how do we simulate construction in Navisworks? The process actually is really simple. We've got this module in Navisworks called Timeliner module. Timeliner module is available here, so I'm gonna pin it on my screen. Timeliner window has got 4 tabs: Tasks tab, Data Sources, Configure, and Simulate. The Task tab is used to create tasks from scratch. Now, this is generally used when you do not have a construction schedule already created. So I could pretty much go and create a task from scratch. I could simply go and say add task, and I can create a task from scratch. So it's like creating your construction schedule within Navisworks. Alternatively, we can automatically create tasks as well. So for example, if I right click anywhere in the gray area here, so anywhere here, if I right click, I can go and say auto add tasks for every topmost layer, item, or set. So let's start with item. Topmost items are basically the items available in your selection tree. So it is going to add a task for each of these items in the selection tree, which means the entire structure model will be installed in one go. Similarly, the entire HVAC model will be created as a single task. Electrical would be single task, and so on. So if I show you an example of that, I can right click here and I can go and say auto add task for every topmost item. So as you could see, it creates a single task for each of these items. It starts from today's date, gives each task a 1-day schedule, and then shows you the animation. I've got my Gantt chart here that I could see. Also, what it does is it automatically assigns or attaches the model to the task. So as you could see here, it automatically attaches the entire structure model to the structure task. Now, if I go and play the simulation of this, it actually would not really make much sense. And the reason is because it's installing entire structure model in one go, entire mechanical model in one go, and so on. So it doesn't make much sense. Now, similarly, if let me delete all these tasks. The next option is automatically adding tasks for every topmost layer. What this would do is it would go and expand each of these items in my selection tree and would create a task for each of these layers. So hospital structure model, it'll create a task for these layers. Similarly, HVAC, it'll create tasks for these layers, and so on. So if I show you an example of this, I'll go and say every topmost layer. There you go. So it creates a task for every topmost layer for each of my models and assigns the layer or attaches the layer to that task. And similarly, if I go and play the simulation, so again, as you could see, it doesn't make much sense because it is just based on layers. But the whole idea is within no time, you can go and create a quick simulation for somebody to look at. Last automated method that we've got is automatically adding tasks for every set. Excuse me. Now, this concept of set is really interesting in Navisworks. Before I get into this, let me hide this timeline window, so I'll explain the sets to you. The concept of sets is where if I have got certain elements that I use on regular basis, I could select them once and I can save them with a name. And the saving of the sets is done in this window called Sets window. As you could see, I've got different folders here, so structure, MEP, architecture, specialty, and so on. If I expand structure, I can see all these different structural elements. Now, there are two types of sets we can create in Navisworks. The first one is called selection set. Selection set is where I can manually select items from my graphics window or from the selection tree, or by using the select same option here. So I can manually select these elements and I can save them with a name. They are called selection sets. Search sets is where we find items based on their properties. So for example, I need to search for all the structural elements. So I could use this window here called Find Items window. In the Find Items window, I can search for elements based on their properties. So for example, as I mentioned earlier, if I go into my structure model, and if I hide everything else, let's say I want to pick all the structural columns, I can click on this structure column here, and in my properties window, I can look at all these different properties I want to search for. So for example, let's say I want to only select structural elements that are columns. So I could go and search for element category equals structure columns. And then I can then further add more criteria to select structural column of level 1 by selecting layers and things like that. So in this case, for example, if I say I'm looking for element category equals structure columns, it's going to go and pick all the structure columns. And then I can go and say element level equals this level 5. So it's only going to pick level 5 columns. Let me show you an example of this. So if I go and say I'm looking for, and the process is really simple. The first selection that you make here in this drop-down list is the tab on which the property sits. So I'm going to go and say E for element. The second value that you select is the property that you're after. So I'm going to click on this drop-down list and type in C for category. And then I'll go and say equals. And the value that I'm looking for is structure columns. So if I simply go and say element category equals structure columns, and I say find all, it go and find all the structure columns, which in this case are 249. It finds 249 structure columns. Similarly, if I want to add structural framing, which are my beams, so beams are listed as structural framing, I can say I also want to select all the structural framing. I can go and say E for element, C for category, equals structural framing. Now, if I was doing a physical on-site presentation, this is where I normally ask the question, when I go and say find all, what do you reckon I'm going to find? Most of the people would say you'll find structure columns and framing both and so on. But basically, we will not find anything. So if I say find all, it says no objects found. And the reason I cannot find any object is because it is now looking for elements that are structure column and structure framing. That's because the additional rows that we add are and conditions. So in this case, I'm going to right click on this second row and I'll change it to or condition. So now it's going to look for element category equal structure column or framing. So if I say find all, it goes and finds 2,265 elements. And similarly, I can go and add structural foundation as well. Alternatively, you can make your search sets smarter by saying, instead of saying element category equals structural columns, I can say element category contains, and now I can type in structural. Press enter. So every time you type in anything in the value field, you got to press enter for it to register the value. Now, by saying contains structural, I can now pick in structure columns because they're called structural columns, so contain structural, or framing because it contains structural, or even foundations and so on. So if I say element category contains structural, I'll go and say find all. It now finds 2,818 items. So in this case, I have selected the entire structural model by picking columns, framing, and foundation. This kind of search set is really handy when you're running clash tests. So that way you are selecting everything in one set. But if you have got search sets to be created for your construction simulation, then you'll have to break them down based on what gets installed first, what gets installed next, and so on. So for example, foundations would go first, and foundation walls, then you've got level 1 structure, then you've got slabs, and so on. So once you've got these search sets created, I can now go into my timeliner window, and I can say right click, auto add tasks for every set. So in this case, it goes and adds a task for every set, and it makes all those tasks as construction tasks as well. Now, because I've got folders available here, not to create a task for the folder, excuse me, I'm going to change this to no task type. Similarly, for all these folders, I'm going to clear their task types. And now I can go and play this simulation. Now again, the problem with this is it creates the task for the sets based on the sequence in which they sit here. So it's pretty much going to create the task for the structure sets first, then MEP, then architecture, and so on. So although it's playing the simulation, but it doesn't make too much sense. And the reason for that is because of the fact that all these tasks are based on the sequence in which these elements sit. So again, this is just to get some initial simulation going, but as I mentioned earlier, it doesn't make much sense because everything basically is based on the sequence in which they sit here.
Deepak, sorry to interrupt you.
Sure.
I think what happened, there was a bit of a confusion about 12 students used another link and they missed earlier part of the presentation. And my concern is, will it be possible to start, if possible, the demonstration because they have missed the initial part of your demonstration because they have just joined because there was some confusion using another link.
Yeah, absolutely. I can start. So do you want me to go back in the slide deck or just the demonstration?
Yeah, if you do not mind, for the there are about 10 students who missed it, so if we could just have a quick preview of where you started from, that would be fabulous. So, my apologies.
Okay, right. No worries, no problem at all. All right, so I'll just quickly go back to the slide deck. So what we were discussing earlier was managing construction changes. So no matter how much we try to plan for construction, no matter what kind of program we use, there are always changes in various construction tasks. And these changes could be because of weather conditions or other natural causes that are out of our control. And the times we are living in is a very good example of what could be the reasons that the construction tasks get delayed. So, for example, in the times we are living in, maybe there's a shortage of delivery of elements, or there's a supply chain problem, or there's labor problem, and so on. So because of these reasons, the construction tasks are delayed. Now, once you delay a particular construction task, they've got effects on other tasks directly or indirectly. And the example I mentioned earlier was, let's say we were supposed to pour the ground floor slab last week, and for some reason we could not pour the ground floor slab. Again, it could be because of the rain, it could be because of the other problems, labor problems, and so on. So because we could not pour the slab last week, it now has got flow-on effect on other tasks like steel erection and things like that. So as construction managers, it's really important for you to understand the changes and what effects these delayed tasks would have on the other tasks. The problem is that if you're only looking at the construction schedule, it's really hard for you to understand and visualize what would be the changes that would be applied to the other tasks, or what flow-on effects these delayed tasks would have on the other construction tasks. And this is where BIM-enabled environment provides us the foundation to visualize these changes. So a BIM-enabled environment is where you've got all the metadata plus the 3D model to visualize the project and also the elements in the project. And Autodesk Navisworks allows you to look at that BIM data that you've got available and then run planned versus actual simulation to assist in visualization of these changes. So for example, let's say for some reason we could not erect the steelwork on level 1 and level 2 on time. So obviously these tasks are delayed. Now, once these tasks are delayed, what are the flow-on effects on the other tasks? In a BIM-enabled environment, Navisworks allows you to visualize those changes. So what are planned versus actual simulations? In these simulations, there are two types of dates that we've got. We've got the planned dates, now planned start and planned end dates, which means, let's say the planned start date to pour the slab was last week's, let's say 14th of March. And the planned end date to finish pouring the slab was 21st of March. So they are planned dates, but actual dates are the dates on which the task actually was started and finished. So let's say we could start the pouring of slab on 14th of March. It started on 23rd of March. So that's the actual start date. Similarly, we've got actual end date. So these are the tasks where we've got the planned and actual dates. And once we've got these two types of dates, Navisworks then lets you play planned versus actual simulation. And you can then display the tasks that are late or that are delayed in different colors. So the idea is that those tasks will then help you visualize what are the elements that would be delayed or that are delayed, and what could be the flow-on effect in the construction schedule. And this is where I went on to the live demonstration. The demonstration is done using this project that I've got available, which is a multidisciplinary hospital project. I've got structure, mechanical, electrical, plumbing, architecture models here. So for example, if I go into the HVAC model, this is my HVAC model where I've got all my ductwork, my mechanical equipment, and things like that. Plus, I also have got some other elements which are like cranes and these temporary constructions. So these are different temporary items that we install that would help us in actual construction, which could also include scaffolding, as I was mentioning earlier. So what Navisworks now does is it lets us play simulation, and that's done by using this window here called Timeliner window. So Timeliner module lets us create different tasks in this tab called Tasks tab. There are other tabs called Data Sources, Configure, and Simulate that I'll explain in a few minutes. So on the Tasks tab, we can create a task from scratch. So I can simply go and say Add Task here. It lets me create a task from scratch. So I could create a task to install crane, for example. I can create a task to install or erect steelwork, for example. Alternatively, we can create automated tasks. So automated tasks are of three types. I can create automatic tasks for every topmost layer, item, or set. Starting with item, as I mentioned earlier, if I say for every topmost item, it would then go and create a task for each of these files, which are treated as items in my selection tree. So for example, if I go and say every topmost item, it now goes and creates these tasks. It starts with today's date, gives each task a 1-day schedule, and automatically attaches that item from my selection tree to the task. So if I go to the Simulate tab, let me just quickly change this to this. So I can now go and play the simulation where it's showing me the construction simulation of these. But as you could see here, it's using, I'll play it in full screen mode. So it's using an entire model as one single task, which doesn't really make sense. So in this case, it's doing the electrical, and similarly, it'll do plumbing and then architecture in one single go. So it doesn't make too much sense when we are doing it this way. If I go and delete these tasks, I can go and say auto add task for every topmost layer. By saying layer, it basically goes into each of these models and looks at the layers of these models and creates a task for each layer of each model. So for example, if I go and say auto add task for every topmost layer, it now goes and creates a task for each layer of each model. And you can see this here. And it attaches the layer to each task. So it's now attached this layer to this task here. And again, I can go and play this simulation. So all that's playing the simulation, but it doesn't really make sense because it is totally dependent on the sequence of the file that were used to create this federated model and the layers in them. And the last option that we've got is for every topmost set. So in Navisworks, we've got this concept of sets. As I was explaining earlier, there are two types of sets we've got available. We've got selection sets, where I can manually go and pick elements, and I can save them as a set. And then we've got search sets. Search sets are the sets where we select an element, and we look at their properties, and we search for those properties. So for example, in this case, these are structure columns sitting on level 3. So that's top level is level 3. Similarly, base level is level 1. So these are level 1 structure columns. And we perform these searches in this window here called Find Items window. Find Items window would let me find items based on their properties. Now, I strongly recommend people to not use selection sets. They should be using search sets. And the main reason is because when I go and manually select elements and save them as selection sets, they are static. Now, what I mean by static is they are static sets, means if tomorrow the model is modified and there are more columns added on level 1, when you refresh your model, the selection set will not include the new level 1 columns because they are static sets. Whereas when you use search sets, irrespective of what elements were available when you created the search set and what elements were not available, when you click on the set next time, in the background, it runs that search criteria that was used to create the set. So structure columns or structure framing sitting on level 1. And if there were new elements added, it would pick those as well. So the search sets are dynamic. They automatically add or automatically select new elements that got added after the change in the model. So it is strongly recommended not to use selection set. You should be using search sets. Now, once you've got search sets available, I can now go and create automatic tasks based on all the sets as well. So I can go and for every set. Now, in this case, again, what it's done is it's gone and created these tasks for each of these sets. It also creates a task for each folder that I've got available here. In this case, I'm going to change the task type for the folders to blank because we are not simulating the folders. We only want to simulate the tasks based on the sets in those folders. And now I can go to my Simulate tab, and I can play the simulation based on this information. I'll press the F11 key to play the simulation in the full screen mode. So now this is a little bit better from the last one, but again, the problem here is it is playing the simulation based on the sets and the sequence in which they were sitting in the sets window. So if I would have placed the mechanical, electrical, plumbing sets above structure sets, it is going to just go and install mechanical, electrical, plumbing items before even installing structure other elements. So as far as it looks good, but it's not realistic. I'll press F11 to go back to the main screen again. I'm going to stop this simulation. So I'm going to now delete all these tasks. So what we need to do is we need to either go and create these tasks manually in the proper sequence in which they should be installed or constructed or erected, or alternatively, if you've got a data source already created with your construction schedule, you can import that. If I go to the data sources tab in my timeline window, and if I click on this add drop-down list, I can add a Microsoft project file, I can add a Primavera web services, or I can even directly link an Asta project. Now it's not showing me Asta here because I don't have Asta installed on my machine, but if I had Asta installed on my machine, it shows me that as well. Now personally, I'm not a big fan of directly linking these schedules, and the reason is, especially with programs like Primavera, you need to have the web services maintained, which is pretty hard to do in some cases. Normally, what I recommend is to export a CSV file from your schedule, and which is pretty much what I've done here. So if I quickly go to this folder here, I've got this schedule available in a CSV format, and if I show you the CSV file, I've got a column called name, in which I've got the names of all these tasks that I need to perform. I've got my start date and I've got my finish date. So these are my planned start and planned end dates. Similarly, I've got my actual start and actual finish dates as well. Now the task type that I've got here are construction tasks. And these are the task type that would define how the elements are going to be displayed during my simulation. I'll explain this in a sec. And then I've got some columns that define the cost as well. So if I close out of this file, I can now link this CSV file by going into this add drop-down list, and I'll go and say CSV Import. It says, where's the file that you want to import? I'm going to go into this file here, and I'll double click on this. And now it displays this dialog box. And by default, all these fields would be blank if you're doing it for the first time. But because I had already done it a few times on my machine, that's why I had these fields already filled. Let me just change them to blank. Right. So this is how this field selector window or dialog box would look like. We've got these columns here. These are the columns that we saw in the tasks tab earlier. Now we need to map these columns to the field coming from our CSV file. So I'm going to say the task name column, if I just quickly go OK here for a sec. So these are my columns that I've got here that you could see in this dialog box. And these are the fields coming from the CSV file. So I'll say the task name needs to be mapped to the name column in the CSV file. Similarly, I can map the task type to Navisworks task type. Now, in a lot of cases, the schedule may not define the task type. So what I'll do is, for your reference, I'm going to not map the task type field, and I'll show you what we can do in the program. Similarly, I'll say planned start date. I'll say this is the start date. Planned end date is the finish date. And then my actual start date is the actual start and the actual finish date. And similarly, I can map the cost columns as well. So this is material cost, labor cost. By adding cost type, we are now making it as a 4D simulation. So for 3 dimension is our model, 4th dimension is time and cost. So we are adding the time and cost to this simulation as well. And I'm going to go and say OK. As soon as I click OK, it says, do you want to map the synchronization ID? I'll say, no, I don't want to. So I'll click OK. Now what it's done is it's now mapped these columns. But if I go to the tasks tab, I will not see any tasks here yet. What I need to do is once I've done the mapping, I now need to right click on this link and I'm going to say rebuild task hierarchy. Now this also needs to be done every time there is a change in the schedule. So for example, the schedule got changed and you have re-exported the CSV file and you have overridden the original file with the new one. I can go and say rebuild task hierarchy. It now goes and rebuilds task hierarchy and I can see these tasks here. It starts with this task here. I've got my planned start, planned end dates. I can see my Gantt chart here as well. If I just take the Gantt chart back. So this is my Gantt chart of all these different tasks. I can scroll down here. But notice that the task type column is blank. And the reason I left the task type column, I did not map it, is because a lot of schedules or a lot of programs may not have the task type defined properly. So in this case, what I could do is I could go and click here. I can go and say construct task type. So by default, there are 3 task types we've got available. Construct is where the elements will get constructed. Demolish is where you're building a new facility by first demolishing an existing facility. So those tasks would be where the elements would start with the original display, and then at the end of the task, they'll disappear. They're demolish tasks. Then we've got temporary tasks. Temporary tasks are, again, as I mentioned earlier, things like scaffolding or temporary construction or cranes and so on. These are the task types that are available by default. You can also go into the configure tab and create your own construction. You can create your own task types. For example, I can create a separate task for cranes. In this case, I'm going to leave it as construct. Now, I can't manually do it for each of these task types. That's because it's such a tedious process. I remember a few years back, we were working on this massive construction in Victoria, and there were 2,000 task types. Sorry, there were 2,000 tasks. So I can't manually go and change the task type for each of these. This is where Navisworks is really smart. Once I've specified the task type for one of my tasks, I can scroll all the way down, shift, select the last task, and then I can simply right click and say fill down. What this does is it goes and applies the task type to each of the tasks here. So this is all good, but now if I go to the simulate tab and play the simulation, it's not going to show me anything. And the reason it's not showing me anything is because I have only defined the tasks, but I have not attached any element to these tasks. So again, the problem is that I can't manually go into my sets and I can't manually attach these tasks to these sets. This is where we've got an automated method to do that, and that's called auto attach using rules. There are 3 rules available out of box where I can automatically attach the name column to the item name matching case. So if these items here were called these tasks names, I could map those, which is not possible. And same thing with layers, it's not possible. But what is possible is for us to create our sets with the same name. Now, there's one little thing I want to mention here. See how it says selection sets here? It's not just selection sets, it also works with search sets. I get this question asked a lot. It only says selection set. No, no. It says selection sets, but it works with search sets as well, which is what we've got here. So basically what it is going to do is it is going to find a search set, which is called structural foundations, exactly the same case as well, S and F in uppercase. And when I say apply rule, it then attaches these sets automatically to these elements here. And now I can go and play my simulation. Before I play my simulation, I'm going to go into my settings tab. I'm playing the interval size as 2. This simulation would be played for 60 seconds. I've got some overlay text displayed, which includes the current date, current time, the number of days into the construction, number of weeks into the construction. For example, I can add this, the number of days, number of weeks. Okay. And now, right now, I'm just playing it as planned simulation. I'll go OK. I'll click the play button and I'll play it in full screen mode. Now this construction is based on the schedule that was created. And you can see on the top left, it's showing me the information related to these construction tasks. So now, as I said, this is based on the actual schedule that was created. If I just press 11 to go back, excuse me. We also have this calendar here where we can go into our construction. We can go onto a particular date and see how the construction would look like on that date. And if we have got the cost information added, it also shows us the cost on that date. So it gives us some information as to, for our cash flow purpose, as to how much cash would we need on a particular day during the construction. So this type of construction is just a planned construction where we assume everything works fine, everything got installed on the date that we planned. But as you could see here, that doesn't really happen. There's our planned start dates and there are planned actual start dates. So for example, in this case, the structural foundation started on the 6th of February, and it was supposed to finish on 26th of February. But for some reason, we could not start it on the right date. It started on 10th of February and finished on 2nd of March. So planned and actual. Now on the configure tab, we can decide how do we want these tasks that are late or early to appear. So I could go and say, if any task is earlier than expected, it should be displayed in, let's say, purple. But the tasks that are late should be displayed in red. So this is the visual feedback that we'll get to find out what are the tasks that are delayed because of some reason or the other. I can also go and create other additional configurations where I can display the late appearance in different color and things like that. But if I just leave it as the default setting right now, now I can go onto the Simulate tab, and under Settings, I can say instead of just playing planned animation, I want it to be played as planned against actual. Now we've got these 4 types of planned and actual simulation. Planned with actual differences, what this would do is it would show the elements getting installed or constructed for planned dates, but any differences to the actual dates, that duration, the elements would be displayed in red color. Similarly, if you are playing actual with planned differences, the planned difference dates would be displayed in red color. Otherwise, it will be displayed in the actual appearance that we have selected. But I prefer planned against actual because in this case, throughout the duration of the task, if they are late, they'll be displayed in red color. red color because that's what we selected in the configure tab. Now, the reason I prefer this is because when you have got large construction with a lot of tasks, it is important for us to clearly visualize what are the tasks that are getting delayed. And if I just display them in red color, for example, 2 days or 3 days over a period of 3 years, it's not going to give you much visual feedback. That's why plan versus actual is what I prefer, and I'll show you what happens in this case. I'll go OK. And you can straight away see that this task is displayed in red color from day 1. That means we can straight away see that this task here is, which is structural foundation, which is available on top left of the screen, is delayed. Similarly, I could go to the next task. Now, this, which is foundation walls, which also overlaps structural foundation, is displayed in red, and so on. So these tasks are fine. This slab is delayed. These columns are delayed. This column slab is red, and so on. So it gives you a very clear visual feedback as to what tasks are delayed. And if I played in proper simulation, I could see that as well. So as you could see, all these tasks are behind schedule. Now, in my case, I made all the tasks behind schedule, so it gives you a proper visual feedback. But in the actual construction, it would only show you the tasks that are red, that are delayed. But for example, these tasks are fine. So the wall installation was fine. All the interior walls were fine. But you'll start seeing some other tasks that are delayed. For example, the inside elements. So it gives you a very clear visual feedback of all the tasks that are delayed and all the tasks that are fine. And as I said, for better understanding, you can also look at these tasks here to see what are the delayed tasks, or you could go through that calendar and one by one click on the next step to get slower visual feedback rather than playing it in a simulation. So if I go press F11, I'm back here. Now I need to be mindful of the time. We need to get some time for the questions. One last thing, as soon as your schedule changes, all you need to do is right click here, assuming that the new file was saved with the same name as the old file. You just click on rebuild task hierarchy. The only problem with rebuilding task hierarchy is as soon as you rebuild the task hierarchy, your attachment and the task type disappears. Hence, it is important to have the task type column mapped if it is available in the schedule. So if I go and say, OK, so my task type column is mapped. All I now need to do is rerun my auto attach rule, and I'm ready to play the simulation. So wherever possible, it's a good idea to map the task type column as well. And as I said, I can play the simulation. So let's say getting into construction, we were able to bring back certain tasks. We were able to start them on time, which is what we have done in the updated schedule. So when I play my simulation, those tasks that are now no more delayed would be displayed in the normal appearance, which is our normal model appearance. So this is all I wanted to show in my presentation. We've got around 8 minutes for questions. So Professor Aziz, if you've got any questions.
Okay, thank you very much, Deepak. Very useful. So I think attendees could either use their microphone or a chat window to ask questions. So I will start with the first one from Maxim. So Max, I think you have, Deepak, alluded to this, but Maxim is asking, I have made a few 4D simulations. The barrier that I faced was matching the tasks from the CSV file to the model elements. I meet the structural engineer and match the tasks manually. Have you experienced that? And is there a more automated way to achieve this?
Yes, absolutely. And this is a very, very common problem that we face. And the reason is because nobody is going to name their models or layers to match the task names. So what I strongly recommend is to create search sets. And normally what I do is I tell everyone to go into the schedule and then copy the names of these tasks here and specify those names as the names of your search sets that you create. Now, for a lot of constructions, it is not possible to create search sets. In a lot of construction, you might have to create selection sets. A good example is on one of the projects here in Sydney. Actually, it was University of Technology Sydney building. There were certain elements that did not have the right layers assigned to them, which means that we could not say that this ductwork is sitting on level 1 or level 2 and so on. In that case, we had to create a selection set. But the idea is to create your search sets and selection sets and then copy and paste the names from your schedule. That's one important thing that I want to mention here. Again, a problem that we found was that when we copied and pasted the names from the sets, there was from the task, there was an extra space here. And that extra space got copied in the sets name. But when we mapped these columns, that extra space did not appear in the task name here. So there was an extra space at the end of the search set, but not the task. And none of the automatic mapping worked. So they were scratching their head for a couple of days and they came to me. And accidentally, I found that information. I wasn't really looking for that information. Accidentally, I found, because I clicked on the name of the set and there was an extra space here that I could not see here. So in answer to your question, it is better to create your search set or selection sets and copy and paste the name from your tasks in the schedule. That's the easiest way.
Okay, thank you very much, Deepak. So any other questions from the attendees? So while we have got a few minutes, Deepak, will it be possible to just give us a brief synopsis of BIM 360 and how it integrates with Navisworks?
Yes, absolutely. So BIM 360 is a program that allows you to host your models on the cloud. So, for example, if I go into my BIM 360 program here, now BIM 360 is as of saying, I want to use Microsoft. Now, what product of Microsoft you want to use? Excel, Word, PowerPoint, and so on. So that's where BIM 360 has got a number of different modules. So we've got BIM 360 Design, which is where your Revit model is hosted on the cloud and you're working off a cloud-based model in a collaborative project. So for example, you've got distributed teams sitting in London, Sydney, Melbourne, Paris, and so on. You could host the model on the cloud and you could have teams working from different locations from the same model in a collaborative environment. Then we've got BIM 360 document management, which is like your file repository where you upload the models and you can create issues and assign issues and so on. Then model coordination is cloud-based clash detection, where it automatically runs clashes between different discipline models and gives you like a tabular form of the clashes. Field management is where you've got field executives going on site, creating issues, taking photographs, running their checklists, running their safety checklists, etc., etc. So that module. But the underlying file repository layer is this one called document management, which is BIM 360 Docs. It's got a lot of different users. The main program that we've been using around the world is this one called Design Collaboration. So Design Collaboration, as I mentioned earlier, lets you host your Revit model on the cloud and lets you work within your own team or also in multidisciplinary environment where you can share your designs with other consultants. For example, structured consultants sharing their designs with electrical, mechanical, plumbing, and so on as well. So once the project is hosted on the cloud, for example, in this case here, You could go into any of these folders if you've got permissions. So it is totally dependent on what permission you've got to what folder. As you could see in this case, the mechanical model is up to version 29. So as you are changing your design, it's also keeping a version history. You can then go into version history. You can also compare different versions and so on. So for example, for this hospital HVAC model, I can open this model on in my browser, so I don't need any design program. I'm opening this in my browser here, and I can look at different elements. But most importantly, as a construction manager, you could compare different versions of the model. So I can say I want to compare version 29 against, let's say, version 26. So when I go and say, I'll do it in this view. So what it does is it shows you all the different differences between different versions of the model. What are the elements that are modified? What are the elements that are deleted? What are the elements that are added, and so on. So it gives you a really good visual feedback of the changes in different models.
Okay, thank you very much, Deepak, for clarifying.
No worries.
Really appreciate the time you have taken to talk to us, and I think it was very enlightening. I have a few questions about where to access the recording of this session, so I will be sharing a link. So either you could access it through the module website, but those who are not registered into this module, you could either drop me a line and I will be able to share the link with you. So once again, Deepak, I will thank you very much, and I wish you all the best during this time.
Thank you, Professor Aziz. I actually want to thank you for giving me the opportunity. As I said, I really love talking to students, and thank you for the opportunity.
Perfect. Thank you, and all the best.
Thank you.
Cheers. Bye.